Hello everyone, welcome to NumPy course. So today's session we'll be learning about the new functionality that is nothing but your broadcasting method. So first thing we should know about what you mean by broadcasting. So it is used to refer how NumPy library handles the different dimensional of array. So different dimensional array, it will be working in 1D array, 2D array, as well as you can work with the n-dimensional array with the help of broadcasting. The main thing, the basically this broadcasting is used for a arithmetic operation. Whenever you want to do all the arithmetic operation that particular time, we are using the broadcasting method. With the help of broadcasting method, we can perform all type of arithmetic operation. Examples like your addition, then move to your subtraction, multiplication, division, modulus operator, etc. So those operation it's done by through the broadcasting, and it's depend upon the shape also. Shape is nothing but your dimensional b. So if it is a 1D, so whenever you do this addition operator, always remember the two array, whatever the arrays you are adding, two or three, the things will be same. Like if you are using A as a 1D array, size as well as the size should same. The same way if you use in their 2D array, it will not work. So whatever the variables we are taking to add the two operation should be a same data type, and you can move to the different data type by size will be same always. Size will be same always, and then move to the dimensional, that will be always same. So it should be 1D, 2D or 3D, it will be same. So it follows this principle to do the broadcasting operation. Let's take first example here. You can see this is one example for your broadcasting. Here we take a 4 cross 3 matrix. So here the 4 cross 3, B is a 3, we're just taking a 3. So if you observe, this is three values are there. Here also the three value. Equality is there. Yeah, in this there is nothing but by default whenever you are taking, it's taking the values in a sketch. So just we'll doing the addition operation with the 0 plus 0. How much is 0, right? So it's taken a 0. Then move to 0 plus 1. 0 plus 1, it's 1. It's converted to 1. Same way 0 plus 2, 2. Now move to 10. If you observe with that, here it's 10, 11, 12. So if you take B3, because the first variable is 4 cross 3, by default it will take 4 cross 3, and you are giving this, but the other rows which is not there, by default it is taking the same value what is there in the first values. This is the first values, it's taking the all. Now it will add it and it will give you this result. So this is what the broadcasting mainly used for. So let's move to the another example where you'll understand the main thing how the properly it's working on. So I'm taking one more example here to understand the broadcasting. This is one matrix, right? How the previous matrix is going on, it's 4 cross 3. Here also we are taking a 4 cross 3. So this is also a 4 cross 3. 4 cross, just a minute, it's 4, yeah, 4 cross 3, and here it's just a 4 or 4 cross 1 you can take. So this is the values we are taking, 4 cross 1. So this is the things we are taking. Here also we are having 4 cross 3. So first it's added the things 0 plus 0 0, 0 plus 1, y it comes to 0, then 0 plus 2 0, then 10 plus 0. So what happened, it's taking the same values here. So 1 and 2 is there, but it's taking first the same thing equality, then you are adding here. So what it's done, whatever the values are there, it's taken here 0 0 0, 10 10 10 20. So the same values 4 cross 3, it's just giving the opposite way because the addition will be main thing will be here. This will be our main output. This is our main output. Here 4 cross 3, 1, 2, 3. Now, why? There is nothing is there in that when you are giving, it's empty, right? It's a null values, empty. So when we use a concept called broadcasting, there empty will not take. Whatever the values are there in the first rows, these values will be repeated till the last. So you can observe it's repeated. Same way to see this one 4 cross 1, and then it has a 1 cross 3 matrix. So we have at this value, it should not be null. So whatever the values are there, it's nothing is there null, but the same value will be repeated and it will be 4 cross 3, because when you add it here also 1 cross 3, but we have to go with the 4 cross 3, because broadcasting always follow the same values equality. So here also we get the same values, and then if you add all these things, you will get this result. So this is how the broadcasting is working for. I hope you understand the broadcasting principle, how it will work. Let's move to see in a Jupyter notebook how we'll be working on a directly in a practically in a Jupyter notebook. So let's start with importing first. So we'll import NumPy first. Import NumPy as NP, and then move to create a two variable, because we want to do the broadcasting with the, we'll start with some multiplication, addition, subtraction. So let's start with the variable name to start creating. So var equals to np dot array, and then I'll start with a normal 1D array. So 21, 34, 56. So one variable is done. Now move to the another variable. Suppose var1 equals to np dot array, and then it's continue with your 34, suppose 67, and then 90. And then let's do the mathematic operation to save it. Suppose I'm doing the summation of that, or addition to sum equals to your var plus var1, and then move to print sum. Let's run. So you can observe that. So this is the way how we have to do the normal additions part, normal addition with the 1D array. I'm just using some 1D array to work on this. We can go with the this is an integer type. You can go with a float type also. Let's see, just take the same example. I just converted in a float types. So 2.1 to 3.56, 0.356. Let's move here. 0.6, 34.34. Yeah. Yeah. Now what happened? Yeah. So you can observe that you can do the things will be with the summation of the float type also. So you can go with the summation, or you can go with the multiplication, subtraction. So it's depend upon you which operation you want to do that. So I just want to show you one more operation. We'll go with the multiplication operation. The same value I'm taking as a 1D array. Just want to show you the multiplication. I just want to change the name here, mul, and just print the multiplication. MUL. For two-dimensional array, will be start with the creation of two-dimensional array. Suppose I'll go with a variable name, anything variable name you can take. A equals to np dot array, and I'm just start creating that particular array the same way. 1 comma 2, then comma we move to 2 comma 3, and then we are continue with 4 comma 5. So I hope that much is enough. 4 comma 5, we created one array. Then move to the another array. Here one array. Let's move to the another array for the creation. I just take a copy on this. Just change the variable here to see. See, if you know how to create a particular array, that is enough to do the operation. So broadcasting is nothing but you have to go with the same type of the size. So if you observe, I'm doing the same size and same categories to do the broadcasting. So now sum equals to a plus b. Sum equals to a plus b. Then move to the print part, print of sum. Now we can observe that we got that particular result. So the same way you can go with a multiplication. So suppose you change it in a multiplication, you will get the multiplication result. The same way you can go with the subtraction. So you'll get the subtraction result. The same way you can go with the division. So that's depend upon you, how we have to take over this for the two-dimensional array. So this is what the broadcasting work for.